everyone. Today I am going to demonstrate through this model the principle of reflection and most importantly refraction through the working of lenses by making a projector. The primary materials used are a box, a looking mirror which is inside this box, a magnifying glass, some card sheet used to make bellows. To support and fix this model, paint and supporting foam have been used to prevent light from escaping or entering. Let's see what happens when we keep our device at the top and switch off the light. We observe that the phone screen is projected on the wall. This is because of a simple principle of light, reflection and refraction. Reflection refers to when light bounces off from a smooth surface, whereas refraction refers to the bending of light when it passes from one medium, for example air, to another medium like glass. An easy way to understand this is how we can freely run in open air, whereas our speed slows down immensely when we walk through water. The same phenomenon happens with light. When the surface is curved, like in a lens, the light behaves slightly differently. It totally depends on the angle at which the lens is curved. In a biconvex lens like this, when light rays come parallel, as in this case, they converge to one point called the focal point. A perpendicular to the surface on which light falls is known as the normal. As seen in this diagram, when the parallel ray of light approaches the lens surface, it bends towards the normal at a specific angle. When the light ray escapes, it again passes at an angle which causes it to bend away from the normal. The same case is seen with other light rays. An image is formed at the point at which they meet, which is the focal point. The image in this case is going to be magnified. The more the distance from the focal point to the lens, called the focal length, the more magnified it is. But the projected image is going to be dimmer as the light rays from the light source, which is our device, is going to be spread out further. Now considering the mirror used. When we keep the phone on the top, light rays go to the mirror, which is placed at an angle of exactly 45 degrees. Due to the angle of the mirror, light rays coming straight from the top are reflected perpendicular or at a 90-degree angle, rays from the device. This can be explained by the laws of reflection. It states that the angle of incidence, that is, the angle formed between the normal and the incident ray, is equal to the angle of reflection, the angle formed by the reflected ray and the normal. Since the rays strike at the mirror at exactly 45 degrees, they leave at 45 degrees. And since all angles on a straight line sum up to 90 degrees, 45 plus 45 plus another angle should equal 180. Thus, the angle which is formed between the coming rays and the reflected rays is 90 degrees. Therefore, the phone screen is now reflecting off the mirror. Since the rays are parallel to each other, as I have already said, when parallel rays hit a biconvex lens, they converge and form a magnified picture. This proves the principle of light reflection from a smooth surface like a mirror and its refraction, especially from a biconvex lens. Leaving apart the mechanism of the projector, an important factor was the cover, which is colored black. The cover is essential as it prevents the light from escaping and it allows its rays to only hit the mirror. A reason for it to be colored black is that it is the only color which will effectively allow the light to pass through straight. What is really interesting about the model which we observe is that the distance from the screen to the projector is proportionate to the distance of the device at the top from the mirror. The closer the projector is from the wall or the screen, the farther the device has to be from the mirror. As we go further from the wall, we have to decrease the distance of the device from the mirror. Thank you.